Hi guys, this is Mr. Urrego, and today we're going to prove identities using double angles. Okay, so here we go. So right now we have an identity. Okay, remember the idea of an identity is to prove the left side equal to the right side. You only work on one side at a time. Okay, so we have cotangent of x equals sine of 2x 1 over 1 minus cosine of 2x. I see a 2x there, so that means a double angle. I have to prove this side equal to the other side. My advice all the time, I have my identities on the right side. Okay? My advice is leave everything in terms of sine and cosine. And hopefully it's going to turn into something that we can work with. So, example, cotangent. What's cotangent? Is the inverse or the reciprocal of tangent, which is sine over cosine. Therefore, cotangent is cosine over sine. So I'm going to write cosine of x over sine of x, and that's cotangent. I see a double angle here, so let me write what's sine of 2x. Sine of 2x is 2 sine of x times cosine of x. Remember, x or theta is just the angle. So here we go. The bottom I have 1 minus cosine of 2x, and cosine of 2x is any of these three identities. So which one should I use? That's the question. So before I start going crazy and doing whatever, I want to see what I'm doing right now. So first of all, let me get a different color pencil here, blue I guess. So I see that I have cosine over sine on the left side. Therefore, the right side has to be equal to this. I have cosine on the right side. I already have cosine on the right side. So I'm on the right track. But this 2 sine of x, I don't need it. So somehow I have to cancel that. Instead, I see a sine on the denominator. So the only thing at the end that I want here is just a sine. Okay, so I see that I need sines on the bottom. Should I do cosine squared minus sine squared? No, I need sines on the bottom. Remember, I'm replacing the cosine of 2x. I'm replacing by any of these three identities. Okay? Any of them. So what I want to do is do something that is referring or that has what I need. I need sine on the bottom because that's my left side. Therefore, let's do sine on the bottom. Sine, I see here 1 minus 2 sine squared. Let's try that one out. Now, by the way, doesn't matter which one you use at all. Whatever you use will give you the right answer. The problem is sometimes you can get faster to your answer. So let's go. 1 minus cosine of 2x is 1 minus, parenthesis, cosine of 2x. Let me use 1 minus 2 sine square of my angle, which is in our case is x. Okay, let me continue. Doesn't matter, again, you can use any of them. The difference is that some of them will have more steps. Let me keep working on the right side. So I have 2 sine of x times cosine of x. Let me work that denominator. 1. This negative will affect this 1. So this 1 will turn into a negative 1. This negative will affect that negative 2 sine. Negative times negative will become positive. 2 sine square of x. Let's stay on the right side. What's going on with this 1? 1 minus 1? 0. That cancels out. So let me bring the top. 2 sine of x cosine of x over the 1's cancel. 2 sine square of x. Look at those 2's. Cancel out. I have sine squared on the bottom. Having sine squared on the bottom is the same as sine of x times sine of x. Alright, so technically I can cancel one of those signs with one of those signs from the top. Therefore, what do I have here? I have cosine at the top, and I have 1 sine on the bottom, which is what I have here, cosine of x over sine of x. Therefore, I just prove that my left side is equal to the right side. So that's the idea, that's the goal. Okay? Again, you can use any of those three identities. Let's try one more. So they're asking me, verify this identity. Sine of 2x minus tangent of x equals tangent of x. So I see that I have sine of 2x, therefore I bring that identity. I have the cosine of 2x, I bring that bunch of identities. Okay, again, the idea is to not have any of these double angles or tangent. I want sines and cosines, and I go from there. Sine of 2x, 2 sine of x times cosine of x, minus tangent. What tangent is? Sine over cosine. Let's go to the other side. Tangent, sine over cosine, times cosine of 2x. Okay, now here comes the question again. What do I want? I have 2 sine of x cosine of x, and then sine over cosine. On the left side I have a minus, on the right side I have no minuses, so somehow I need to work with any of this side. Okay, for now let me keep this 2x and let's work on the left side and see what else can we do. The reason I'm working on the left side is because I have a minus here, and then I have a fraction over 1, and then I have a fraction over cosine. So I want to see, after I solve these two fractions, what would I come up with? And depending on whatever I come up with, then I'll check my identities again. So let's work with this. Let me change the color real quick. So let's go with red. So I have 2 sine cosine of x over 1 minus this. Remember, I want to have the same denominator. Therefore, I need a cosine here, so I got to multiply times cosine of x on the bottom and times cosine of x on the top. Okay, now I have cosine of x as my denominator because cosine times 1 is cosine. The top I have 2 times sine of x, but I have cosine of x times cosine of x, and that's going to give me cosine square of x. Minus sine over cosine. Nice. They have the same denominator. Therefore, cosine of x, and now I just bring everything together. Sine of x times cosine square of x minus sine of x. Okay, one more thing. I still have a minus in between. So the only way that I can get rid of that minus is, guys, look at this. I have a sine of x here and I have a sine of x there. Can I do a common factor? Yes, I can. Common factor. So let me do common factor of sine of x. Sine of x as a common factor. So I have 2 sine of x cosine of x squared divided by my sine of x. Sine of x will cancel out and I will have 2 cosine of x squared left. Minus sine of x divided by sine of x will give me 1 over cosine of x. Okay, so now look at this. Sine over cosine, alright, which is what I have here on the right side. And then I have this, 2 cosine square of x minus 1. Is that similar to any of these identities? That's right. Okay, so here, I'm going to put it underneath. Let me get, I guess, black. So the sine over cosine remains. I'm working on the left side. Times 2 cosine square of x minus 1 ended up being cosine of 2x, which is what I have here on the right side. So the idea is, I didn't know if I had to work with the cosine of 2x at the end. I just tried to do something, all right, and make sure that it makes sense. And right now that, once I have the minus here, that was the trigger. I have a minus. That means I got to combine this somehow. And then I realized that I have a sine as a common factor. Okay, as a common factor. That was, I guess, one of the final decisions there. And once I got that as a common factor, then there's two things that are multiplying. because remember, I always want to see where I'm going. Okay, I have here sine of x and combined with the cosine. All right, but then I have a minus. On the right side, I have the sine multiplying cosine of 2x. All right, so keep in mind, you always look where you're going. I ended up having this, and then, same thing as the cosine of 2x. All right, guys, there's not only one way how to do these identities. There's multiple ways. The main idea is once you see that you have double angles, okay, solve them. Put it as a single angle and see what happens. If you have something to the second power, see if there's an identity like that. If not, remember, you also have the Pythagorean identity, which is sine square of x plus cosine square of x equals 1. Sometimes when you have squares, you can relate those as well. All right, so you never know what's happening. That's the idea. Okay, I hope this helps. Please subscribe to the channel. Let's get to 1,000 subscribers so I can start streaming and help you more. Okay. All right, guys, like the video, subscribe to the channel. In front of your face, you have a subscription to the channel. Please hit that button, and also you're going to see the pre-calculus library. Okay, we're going to have a bunch of videos that's going to help you out for pre-calc and algebra 2. All right, guys, thank you for watching. Take care.